Hi everyone. Okay, your favorite trig functions. We are going to look at the derivatives of trig functions. So we're actually going to start pretty simple and we're going to look at this graphically. We're going to find the graphs of sine x and then cosine x, and we're going to graph their derivatives using the numerical derivative feature of the calculator to find those derivatives. So go grab your calculator. Okay, so we're going to open up a graph page. We're going to graph sine x in F1. And then in F2, we're going to use our template key and the derivative with respect to x of, and instead of retyping sine x, and you'll see why in a moment, we're going to do F1 of x. So now our derivative is graphed in red. So our function is graphed in blue and our derivative is in red. So look at this red function. What is that function? That should be familiar to you. I'm actually going to change this to a trig zoom for you. Okay, menu, window zoom, window settings, and let's have this auto be pi over 2, just so it makes it a little easier for you to recognize. There you go. What is that function? That function is cosine x. So when the function is sine x, the derivative of sine x is cosine x. All right, now the next one we want to look at, I'm going to tab up and I'm going back to function 1. So now instead of sine x, we want cosine of x. And when I hit enter, it's going to change everything. That's why I use the derivative this way. As soon as it graphs cosine, it's also going to graph its derivative. So the blue is cosine x, and now this red graph is the derivative. What is that function? That is not sine x, because from 0 goes down then up. That is negative sine x. So when the function is cosine x, the derivative of cosine is negative sine x. Okay, so hopefully you have everything down that you need to have down, because now we're going to use those two rules to help us find the derivative with respect to x of the tangent of x. Now, how can that help us? Because wait a minute, what is tangent? Tangent, remember, is just sine x over cosine x. So we can take that derivative if we use the quotient rule. So the quotient rule says take the derivative of the top. So the derivative of sine is cosine x times keep the bottom cosine x minus keep the top sine x times the derivative of the bottom, derivative of cosine x is negative sine x, all over that bottom squared. So now cosine x times cosine x, remember, is cosine squared x, not cosine x squared. And a negative sine x times a negative sine x is a positive sine squared of x. And we don't usually write cosine x in parentheses squared. We write cosine squared of x. Now you should also remember this is a Pythagorean identity, that cosine squared x plus sine squared x is 1. So this is 1 over cosine squared x. But that's another identity. 1 over cosine is secant x, which means 1 over cosine squared x is secant squared x. So you have just analytically proven that the derivative with respect to x of tan x is secant squared x. Look at that, you derived the derivative. Let's try another one. So here, now we're going to do the derivative with respect to x of secant x. But what is secant? Secant is 1 over cosine x. Now we haven't learned the chain rule yet, so we're going to use the quotient rule again. I know some of you know the chain rule from last year, but I'm not going to require anything that you haven't learned yet this year. So the quotient rule says take the derivative of the top. So the derivative of 1 is 0 times keep the bottom minus keep the top. And the derivative of the bottom cosine x is negative sine x, all over the bottom squared. So the first part is 0, and a negative 1 times a negative sine x is plus sine x, all over cosine squared of x. So this is just sine x over cosine squared of x. Now that might look like you can't simplify it, but indeed you can. What if I factor out one of the cosines from the bottom? Now does it look more familiar to you? Of course it does. 1 over cosine x, that's just secant x, and sine x over cosine x is tan x. So you have just shown that the derivative with respect to x of secant x is secant x tan x. Ta-da! Now, let's summarize some of the things we know. We found graphically that the derivative of sine x is cosine x. We found that the derivative of cosine x is negative sine x. We found that the derivative of tan x was secant squared x. And we found that the derivative of secant is secant x tan x. Now, my suggestion to you is to know those 4. You really should know all 4 very quickly. But some people only like to know the first column, because it turns out that if you look at the first column and the second column, notice sine becomes cosines. It's the negative co-functions. Then we put a negative, and cosine becomes its co-function sine. Well, guess what? If I have the derivative secant, but it becomes cosecant, then we negate it. Secant becomes cosecant x, and tangent becomes cotangent x. And if I want to change the derivative tangent to the derivative cotangent, I negate it, and secant becomes cosecant squared x. And then, of course, there's always the option, just know all 6 derivatives. Sometimes that's just easier. Whatever works best for you, that's what you want to do. All right, 2 little problems here. We're going to find the derivative of dy dx. So our first example, y is cosine x tan x. So the derivative of y is dy dx. In order to do this, we're going to have to use the product rule. So the product rule tells us to take the derivative of the first. The derivative of cosine is negative sine x, keep the tan x, plus, now keep the first part, cosine x, times what's the derivative of tan x? That is secant squared x. So this looks like you can't simplify it, doesn't it? This is negative sine x, tan x, but what's cosine times secant? They're reciprocals, right? That's 1. And there you go. Technically, yes, this is negative sine squared x over cosine x plus 1 over cosine x, which is 1 minus sine squared x over cosine x, which is cosine squared x over cosine x, which is just cosine x. Now, this is the better answer. Now, do you know the easier way to get that? Remember this original problem? That original function is just sine x. So the derivative, of course, is going to be cosine x. Isn't that awesome? Let's do this derivative. Y is cosine x over x. So we're going to have to use which rule? Quotient rule. So the derivative of y is dy dx. Quotient rule says take the derivative of the first, which is negative sine x, times keep the bottom. Now sneak that x up front so it doesn't look like part of your ankle. Minus keep the top cosine x, and the derivative of the bottom is just 1 all over the bottom squared. And that is it, my darlings. And we are finished. We're going to stop here for today, and I'll see you guys soon. Have a great day.